Hello everyone, so here's a video for 61 through 80 for your final review. Okay, so for number 61, we're graphing a secant function. So remember for these, you kind of want to graph a template function first, and that's going to be y equals -4 cosine of, and remember x over 3 is just a fancy way of saying 1/3 x. So we're going to graph its flip, and then actually flip the fraction to get the secant. Flip the function to get the secant. Okay, so let's answer all the questions about this graph right here. Okay, so my a value is going to be the -4, which means that my amplitude is 4. So that means I'm going to go up 4 and I'm going to go down 4. My b value is the 1/3, which means my period for cosine is 2 pi over b. Plugging that in, you're going to get 2 pi over 1/3. Multiplying by the reciprocal, you're going to get 6 pi. So labeling this, you have 6 pi, then you have 3 pi, then you have 1.5 pi, and then this middle one's going to be 4.5 pi. Okay, now graphing the cosine function, you guys remember cosine starts at 0 and whatever the a value is. So the a value for this one was -4, so we're going to start at 0, -4, which happens to be the lowest that this graph can get. So I have no choice but to go up, then up to the highest point, down back to 0, down to the lowest point, and the same thing on the other side. Okay, so if I make this graph, it's going to look something like this. Okay, but that's not really the answer yet because I just graphed like a template of it. I want to see the flip of it, which is secant. So I need to draw on my asymptotes. So let's go ahead and maybe do that in like yellow. So if I draw on my asymptotes, wherever the graph crosses the x-axis, I'm going to have an asymptote. It's going to be here, 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 and here. And then all we have to do is flip the graph. So remember that just means turn happy faces into sad faces and vice versa. Okay, so you guys notice like right here's your pivot point. It's a sad face, so I'm going to turn into a happy face. It's going to look something like that. Here's a pivot point. It's a happy face. I'm going to turn into a sad face. Sad thing here. A sad face turn into a happy face. And you just have these little corners here. It's like half a happy face. So you're going to have half of a sad. Here, the same thing on the side. So your graph looks something like that. Okay, and you guys remember the blue part here, these guys right here, these parabolas, that is your final graph, not the red one. Okay, number 62, just a lot of translations on this one. It's just a regular old sine graph, but kind of a lot going on here. So your a value is 2, which means that your amplitude is also 2. That means that I'm going to go up 2 and down 2, my highest and my lowest points. My b value, the number in front of the x right there, is just a 1. So remember the period for a sine and a cosine graph is 2 pi over b. So this would just be 2 pi over 1, which is just 2 pi. So labeling that, I'm going to have a 2 pi, a 1 pi, a pi over 2, and then this guy ends up being a 3 pi over 2. Okay, now remember, I like doing these last. If you want to do those all at once, that's fine, but I just think it's too much. Okay, so let's go ahead and graph the sine graph. Remember, a sine graph starts at 0, 0. And if it's positive, it goes up. If it's negative, it goes down. Well, this guy had a positive 2, so that means I'm going to go up to the highest point, then back down to 0, down to the lowest point, and then back up to 0. Same thing on the other side, down to the lowest point, up to 0, back up to the highest point, and back down to 0. Okay, but again, you guys, I mean, you could graph this if you want to, but this is not going to be my final answer because I have some translations that I need to do. Okay, so let's see what's happening here. Maybe we could do it in like orange or something like that. Okay, if I have a minus pi over 2 in a parenthesis, this means that I'm moving right pi over 2. And if I have a minus 1 on the outside, this means that I'm moving down 1. So I need to take all of these points that I have on this graph and move them right pi over 2 and down 1. Well, pi over 2, if you notice, the distance of pi over 2 is just one big tick mark, and then down 1 is just one tick mark down. So I'm going to take all of these points. Look at this one, move it right pi over 2 and down 1. Here's a new point. Going to move this guy right pi over 2 and down 1. There's a new point. Take this one, go right pi over 2 and down 1, and just do that to all of these. Right pi over 2, down 1, right pi over 2, down 1, right pi over 2, down 1. Hopefully I'm not missing any of these. but you kind of get the idea, right? And then if you kind of like follow the pattern on the left side here, it's just going to end up being, let's see, it goes up, up, down. It's going to be somewhere right here. Okay. Now reconnecting these guys, it's going to look something like this. Let's try to add little curves in there. So the orange graph is actually going to be your final graph. All right. Okay, now writing the equations for the following. Remember on these guys, we want to split them vertically in half first. So splitting this guy, horizontally in half is this way. Okay, and then this is the old x-axis. This is your new x-axis, which means that it has actually moved down too. So in your equation, when you're writing this, you're going to have y equals blah, 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 but then all of a sudden at the end, you need to move it down too, so it's going to say a -2. Okay, now your y-axis is still here. That means this serves as my new origin, kind of like your new 0, 0. So let's see what's happening here. This graph is starting at 0, 0 and it's going down. So from yesterday, sine starts at 0, 0, but since it goes down, that means it's going to be a negative sine graph. Notice I left a little blank there to fill stuff in. Now, in front of the sine is my amplitude. And you guys, let's look at the height of the waves, right? This wave is going down 3 and up 3. So I need a little 3 here. I know I have an x value here. I just need to find the number in front of the x. The number in front of the x is the number of cycles that this sine graph has in a period of 2 pi. So look, this thing goes down, and then it goes up and back down again. That's one full cycle. So because only one full cycle fit in a period of 2 pi, this b value is going to be 1. And if you just want to clean it up a little bit, it's going to be -3 sine of x minus 2. Okay, and this one we did in class, but I'll do it with you guys again. Clearly a tangent or a cotangent graph. How do you tell? Remember, you tell based off of its asymptotes. So let's draw those guys in. So there's going to be an asymptote here. And then there has to be an asymptote somewhere right here in the middle there. Okay, now let's look at the position of these asymptotes. Well, here's the y-axis, right? If there is one to the right and one to the left of the y-axis, this is a tangent graph. So I'm going to go ahead and write y equals tangent. Now I need to fill some stuff in. So for a tangent graph, you go to the middle of the asymptotes, you move right 1, and then where does the graph take you? Halfway. You don't move right 1, you move halfway to the right. And then where does the graph take you? Well, it takes you up 1, right? So that's your a value. So this is going to be 1 tangent. And then this b value in front of the x is probably the hardest to find. So let's see if we can find a formula that has a b in it. Well, I know that the period for a tangent graph is pi over b. So if I can only get the period, then I could find the b. Well, the period is just like the distance between the asymptotes, right? So you can either look at it this way and go, well, how far is it from here to here? Or you could go, how far is it from here to here? How long does it take until they start repeating themselves? Well, it takes pi over 2 for it to start repeating itself. So that means that the period is pi over 2. So pi over 2 is pi over b. Pi is pi. That means b has to be 2. And again, cleaning this up a little bit, this would be y equals the tangent of 2x. Okay? Okay, let's look at 65. All right, so definitely looking at this one, this is a secant or a cosecant graph. So let's see what we've got. Let's take the blue one and split it in half horizontally. So let's do this. That splits it in half. Now I noticed something here. You guys, this is not only the old x-axis, but it's also the new one. So that means there is no up and down movement. So at the end of my equation, I'm not going to have a plus or a minus anything, okay? Now let's look at my y-axis. I'm going to keep that the same. Okay, now this is my 0, 0. Did it start at 0, 0 this time? No, that means it's not a sine graph. This thing started at 0, 2. That's your 0, comma a. That means this is a cosine graph. So let's go ahead and put this together. So I have y equals cosine. Establish that, okay? And then the a value is a 2. Okay, now let's see what the x is going to be, or the number in front of the x is going to be. So look, here's 2 pi. I need to find out how many cycles of this graph fit in a period of 2 pi. So let's count. There's 1, and then there's another one. So there's 2. So 2 cycles fit in a period of 2 pi. That means my B value is going to be 2. There was no up and down, no right and left, but I'm not done yet, right? That's not actually the graph I'm looking for. I'm looking for this red little dude, okay? So that one is going to be the flip of cosine, which is actually secant. So it'd be 2 secant of 2x. All right, number 66. Again, let's split this thing. Split it in half. Okay, that's my old x-axis and my new x-axis. That's not very exciting. That means, again, no up and down movement, okay? And then you guys drawing this in. Here's my 0, 0. It didn't start there. That means this is not a sine graph. It has to be a cosine graph. So let's see where it starts. This time it starts right here at 0, 2. That means this is 0a. This is a cosine graph. So I have y equals cosine. The a value is your 2, okay? And now let's see what the number in front of the x is going to be. So here's 2 pi. I need to find out how many cosine graphs fit in a period of 2 pi. So let's count. There's 1. Here, I'll do it in different colors so you guys can see a little bit better. 2. And, I don't know, maybe like green, 3. So 3 cycles of this cosine graph fit in a period of 2 pi. That means that the b is 3. And there you have it. Remember, there was no up, down, right, or left. Okay, now it's time to take out your calculators. These are going to take a while to do, so just kind of hang in there. Okay, so find the length to the nearest hundredth of the longest side of a triangle with. Okay, so let's look at this. Remember, it does not say that this is a right triangle, so I cannot use SOHCAHTOA. Here I'm going to use the law of sines, law of cosines. So your A is 49, your B is 57, and then it says that little a is 8. Now, in order to find the longest side, remember the longest side is always opposite the largest angle, right? But I don't know what the largest angle is because I don't know what this angle is, but I can find it really quickly just by subtracting 180 minus the other 2, right? So let's do that. So let's do 180. Oops, it's not working. 180 minus 49 minus 57. Believe it was 74. Yep, this is 74. Okay, now I could tell what the longest side is. So the biggest angle is the 74. That means the largest side has to be opposite. So this is the side that I'm looking for, okay? Now remember, I will always want to try to use law of sines because it's easier than law of cosines. Okay, so if you have an angle on an opposite side, you can use the law of sines. And remember, again, the law of sines said that sine of A over A equals the sine of B over B equals the sine of C over C. And I can totally use that because look, you guys, I have angle A and I have side A. So I could do sine of 49 over 8 equals, and then I'm going to go ahead and use the C part because I'm looking for side C. So I can use 74 and C. I could say sine of 74 over C. And remember the fast way to solve this, I'm looking for C. So I'm literally just going to cross multiply. So that's 8 sine 74, and then just divide by the little leftover, divided by the sine of 49. Now, when you're plugging this into your calculator, please make sure that you are on degrees and not radians. Otherwise, it's going to give you a bad answer. So 8 sine 74 divided by sine of 49. Plug it in with me. Make sure you can do it. And you guys, for this one, I got that C is approximately 10.18 or something like that. Okay. All right, same thing for number 68. Let's draw this one out. Find the length of the longest side. So I've got ABC. I've got that A is 45 degrees, little a is 83, and little b is 79. Okay, so you guys, I'm assuming on this one that this is probably going to be my longest side. Otherwise, I've already, got the other 2 sides. But let's just double check. I need to find out what angle C is. So I need to use the law of sines. So let's go ahead and do that. I'm going to go sine of 45 over 83. So sine of 45 all over 83 equals, and then I'm going to go ahead and do sine of, can't find C, I got to find B. Sine of B all over 79. I just need to find out which one is the biggest angle so then I can figure out what the longest side is. Okay, so again, cross multiplying. Okay, I'm going to cross multiply. I'm looking for sine of b, right? So I'm going to get sine of b equals cross multiply. So that's 79 sine of 45 all over divide by the leftover, which is 83. Okay, now plugging that in, so I have 79. Oops, I think it's turned upside down. I'm so sorry. 79 sine of 45 and then divided by 83. Okay, that gave me about 0.6730 or something like that. So sine of b is 0.6730. Now to find the b, remember I can't divide by sine, but I can take the sine inverse of 0.6730. Okay, so I'm just going to go and do that. I'm going to go second sine and then plug in the answer there. And you guys, for angle B, I actually got that angle B is 42.3 degrees. So angle B is 42.3 degrees. Now, let's find angle C. Let's find this missing guy right here so I can see which one's the biggest one. So again, subtract them from 180. So I'm going to go 180 minus 45 minus 42.3. And that gave me that this is 92.7, which indeed is the biggest angle. That means that this is going to be the biggest side. Okay, so let's go ahead and use the law of sines again. So I can go sine of 45 over 83, sine of 45 over 83 equals, and then I can do sine of 92.7 over c. Sine of 92.7 over c. And again, I'm looking for c, so I'm going to cross multiply, so that's 83 sine of 92.7 all over the sine of 45. Let's plug that in and see what we get. So that's 83 sine of 92. Oh, what did I just do? Sorry. Undo. I don't know what I hit. Sine of 92.7 and then divided by the sine of 40. Is that a 45? I think so. Sorry, it looks like a 41 sine of 45. And you guys, for this, I got that side C is going to be 117.25 approximately. Okay, so that one did take a little bit more just because I don't have enough information. All right, on these guys, so you have triangle ABC. So I have ABC. And it says that little a is 5, little b is 6, and little c is 7. Now, when they give you a side triangles, which is what we have here, and you're looking for the angles, remember there was kind of a trick here. You always find the greatest angle first. Okay, and we're looking for angle C, so I'm kind of crossing my fingers that's the greatest angle, and it is because it's opposite the greatest side, right? Now look, I can't use law of sines anymore because I don't have an angle on opposite side. So this time I'm going to have to go to law of cosines. Because I'm looking for angle C, I'm going to start with c squared equals a squared plus b squared minus 2ab cosine of c. So let's plug everything in. This is 7 squared equals 5 squared plus 6 squared minus 2 times 5 times 6 times the cosine of c. So this is going to give you 49 equals, this is 25 plus 36. 25 plus 36, I believe, is 61. And then this is minus, this is 10 times 6, which is 60, cosine of c. And then if I subtract 61 from both sides, this is going to give me negative 12 equals negative 60 cosine of c. Then if you divide by negative 60, I'm going to get negative 12 over negative 60 is the cosine of c. Two negatives make a positive. And then you guys remember to get that c value, I want to take the inverse cosine. So angle C is going to be cosine inverse of 12 over 60. Okay, and plugging that in, let's see what we get. So second cosine of 12 divided by 60. And that gives me that angle C is approximately 78.46 degrees. Okay. All right, let's look at number 70. Same question. but kind of a cruel version of it. Okay, you have ABC. It says A is 11, B is 12, C is 10. Now it says, what is the measure of angle A? Okay, it seems like it's asking the exact same question, except you guys, it's still a side, side, side triangle, and we have to find the biggest angle first, just to make sure. And you guys, angle A is not the biggest angle. Actually, angle B is the biggest angle because it's opposite the 12. So I need to find that one first just to make sure it's not wrong, okay? So let's go ahead and find angle B. So again, I'm going to do law of cosine. So it's going to be B squared, because I'm looking for angle B, equals A squared plus C squared minus 2AC cosine of B. Okay, so plugging this in, I'm going to get 12 squared equals 11 squared plus 10 squared minus 2 times 11 times 10 times the cosine of B. So this is 144 equals, and you guys, this is 121 plus 100 is 221, and then this is minus, and this is 22 times 10, which is 220 cosine of B. And then if I subtract 221 from both sides, okay, let's see what that gives us. 144 minus 221. Minus 221. Okay, negative 77. So this is negative 77 equals negative 220 cosine of B. And then if I divide by negative 220, I'm going to get 77 over 220. Notice the two negatives made a positive equals the cosine of B. So then B is just going to be cosine inverse of 77 over 220. So let's see what we get. Okay, so we do second cosine, what was it, 77 divided by 220. And I got about 69.5 degrees. So B is 69.5 degrees. So let's put that in 69.5. But I really wanted to find angle A. But now that I have an angle on opposite sides, it's kind of nice. I can use the law of sine. So let's do that right here. So I could do sine of 69.5 all over 12 equals the sine of A all over 11. Okay, again, I'm looking for this, so I'm going to go ahead and write sine of A equals, and then I'm going to cross multiply, so that gives me 11 sine 69.5, and then I'm going to divide by the leftover, which is 12. And let's plug that in and see what we get. So I have 11 sine 69.5, and then divided by 12. And then that gave me that sine of A is approximately 0.858. And then if I do the inverse of that, so sine inverse of 0.858, let's see what that gives us. Second sine, second answer. Okay, I got angle A is approximately 59.16 degrees or something like that. Okay. So that one was a cool version of number 69. I apologize for that. Okay, now let's look at this one. You guys, I believe I changed these in class to make it so they're not two-step problems. So let me go ahead and do that here. So if you were absent, you guys, these were cruel two-step problems. I don't think we did that to you on the final, so I wanted to make it a little bit more straightforward. So look, here's A, B, and C. It says little a is 15, little b is 16, and angle C is 23 degrees. And I think I changed it to find the measure of side C. So again, on this one, I do not have an angle on opposite side, so I have no choice but to do the law of cosines. So since I'm looking for little c, I'm going to start with little c squared equals little a squared plus little b squared minus 2 times little a little b cosine of c. Okay? So let's plug this in. I don't know what little c is, so c squared equals a is 15 squared, b is 16, and then minus 2 times 15 times 16 times the cosine of, look, I even got angle C, which is 23. Now, the nice thing about this is that there are no variables in here, which means I can plug it all into my calculator at once. But I want to solve for C, so I'm going to do one more little thing. I'm going to take the square root of both sides. So my answer is the square root of all of this. And I'm going to plug it in just the way I see it into my calculator. You guys do it with me. Make sure we're getting the same answer, okay? So this is 15 squared plus 16 squared. And then minus 2 times 15 times 16 times the cosine of 23. And I got that C is approximately 2, oh, nope, not 2. Let's try that again. It's approximately 6.257, something like that. Okay? All right, let's look at 72. I apologize, this is a long video. This was a hard part of the review. Okay, we've got ABC. It says angle A is 35, little b is 16, little c is 19. And you guys, I think I changed this to find side A. So again, I don't have an angle on opposite sides, so I have to go with law of cosines. So I'm going to go, because I'm looking for a little a, I'm going to go with little a squared equals little b squared plus little c squared minus 2bc cosine of a. All right, let's plug it in. I don't know what a is, so I'm going to go a squared equals. Then b is 16, so it's 16 squared. C is 19, so it's 19 squared, minus 2 times 16 times 19 times the cosine of angle A is 35. And you guys, the same thing as in the number above, we're going to take the square root of both sides and just plug that in exactly the way that we see it into our calculator. So let's go ahead and do that. So I have second square root, 16 squared plus 19 squared minus 2 times 16 times 19 times the cosine of 35. And I got 10.9 approximately. Actually 10.9066748.9, but 10.9. All right. Okay, now determine if the following triangles have 0, 1, or 2 solutions. Okay, so let's just go ahead and try solving and see what we get. All right, so we've got ABC. Okay, little b is 22, I'm sorry, angle B is 22, little b is 16.8, and then little a is 22.42. You guys notice here, we've got this angle side, right? That's the ambiguous case where you're gonna have 0, 1, or 2 solutions. And what you wanna do in this case, you just wanna try to start solve it and see what happens, okay? So I have an angle and an opposite side, so I'm gonna go ahead and do law of sines. So it's gonna be the sine of 22 all over 16.8 equals, and then I have no choice but to find angle A. So sine of A all over 22.42. Okay, now look, I'm looking for sine of A. So I'm going to write sine of A equals, I'm going to cross multiply, so 22.42 sine of 22 all over the 16.8. So let's go ahead and plug that in so we get. So I have 22.42 and then sine of 22. Then divided by 16.8. Okay, so I got that sine of A equals about 0.4999, which is about 0.5 if you want to round that off. And then if you take the inverse of that, so A is going to be sine inverse of this, I'm just going to call it 0.5, and you should get that A equals 30. Okay, so for angle A, I got 30 degrees. Now look, because I got an answer, that means there is definitely 1 or 2 solutions. The 0 solution is out, okay? So now I need to check for another solution. Let me do it in a different color. So to check for another solution, okay, this angle that I just found, I'm going to find the supplement of it, okay? So I need to find the supplement of angle A. The supplement just means 180 minus 30, so that's 150. Now the question is, could this be a solution? Okay, well, I don't know. Well, let's plug it in. So you guys look, here's my triangle. I know this is 22, this is angle B, and I just found another angle A to be 150. Could that be a possibility? Well, the question is there room for another angle? There is, because look, 150 plus 22 is only 177, which means that leaves room for another angle. So this is a good solution. That means I have one solution and I have another solution. So the answer for this would be 2. Okay, let's try 74. Okay, draw out the triangle. You've got ABC. This time angle B is 96 degrees. Side B is 3, side A is 24. Okay, so for this one, I can already tell what it's going to be, but I'll tell you later why. But let's just go and start solving it. So I have an angle and an opposite side. So I have law of sines. Sine of 96 all over 3 equals, and I can do sine of A over 24. Okay, again, I'm looking for the sine of A. So if I cross multiply, that'll give me 24 sine of 96 and then divide by the leftover. Okay, so this will give me, let's see, 24 sine 96, sine. Okay, I got that sine of A equals 7.956. Now look, when you take the inverse sine of this, the calculator is going to give you a big fat error, okay? That's because the sine of an angle cannot be bigger than 1. Remember, the sine function, the highest it gets is 1, so it can't get up to that 7.956 without changing its amplitude. So because it's an error, this means it is no solution for this guy. Now look, remember I said at the beginning I could already tell what the answer was, and it's because of this. Let me show you, okay? 96, okay? That has to be the biggest angle in the triangle, right? Because these two just have to, right? They have to add up to 180. So there's no way that these two, any of these guys can be bigger than 96 for that to work, right? So if 96 is your biggest angle, okay, then that means that 3 right here, okay, has to be the biggest side. Okay, there's no way that that could be the biggest side, so I could already tell there's no solution. All right, now let's look at these guys right here. 75. Okay, simplify. So on this one, all it's telling you to do is to subtract. So when I'm subtracting, I need a common denominator, and look at that, I already have one. So this is sine squared, right? And they're both already sine squared, they're the same. So the top is just gonna stay 1 minus cosine squared. And we know from our identities that 1 minus cosine squared equals sine squared. So sine squared over sine squared equals 1. Okay, and then number 76. Okay, so for this one, I don't really know what to do. So let's just go ahead and maybe we can, well, I wonder if I could do that. You know, I see something else that I can do that I might do with you guys. This might be kind of fun. I'll show you something. Okay, I'll try a different way and see what happens, okay? So you guys, I'm subtracting here, but I'm basically dividing tangent squared by all of this, and I'm also dividing sine squared by all of this. And since I see a tangent squared and a sine squared in both, I'm going to see if I can do something kind of fun here. Let's see if this will work, okay? You know what? I've never done that before. I'm not going to do it. I mean, it will work, but it's going to confuse you guys, so don't worry. Let's just change everything to sines and cosines. So look, tangent squared is sine squared x over cosine squared x, right? And then I have minus this sine squared x here. I'm going to go ahead and put that over 1 just to keep it looking a little bit nice. And this is all over, again, tangent squared is sine squared x over cosine squared x. And then it's being multiplied by sine squared x this time, sine squared x all over 1. Okay, now look, looking at the top here, let's go ahead and simplify this. If I want to subtract two fractions, I need a common denominator. The common denominator for both of these, if I multiply them together, is just cosine squared x. This is already a cosine squared, so this is going to stay a sine squared. I did not need to change that. And then minus. Now, this one needs to be a cosine squared, so I need to multiply them both by cosine squared. So on the top there, I have sine squared x cosine squared x. And then it's all being divided by, let's go ahead and multiply these out. This is sine to the 4th x all over, if I multiply this out, it's cosine squared x. Okay, so I've got myself kind of a mess here. Okay, I noticed that I have two fractions, right? If you're dividing two fractions, you're actually multiplying by the reciprocal. So let's do that. I'm going to take this, which is sine squared x minus sine squared x cosine squared x all over cosine squared x. And I'm going to multiply by the reciprocal of this, which is cosine squared x over sine to the 4th x. Okay, now look, these guys cancel out. That's kind of nice, right? Now, something else I notice here, do you see how both of these have a sine squared in it? Let's factor that out. So if I factor out a sine squared x, I'm going to be left with 1 minus cosine squared x. Okay, And then I'm dividing by the sine to the fourth. But I also know that 1 minus cosine squared, that equals sine squared. So because that is sine squared times sine squared is sine to the fourth. And sine to the fourth over sine to the fourth is, again, 1. My gosh, these are all equaling 1. Okay, let's try 77. You know what, you guys, 77 is something that you do multiplying by the conjugate. If you wanted to do it, they're kind of silly. I'll go ahead and do it with you guys. And you might be like, what was the point of this? If I multiply by the conjugate, 1 minus cosine of x, it becomes something that's very similar. That's why I didn't do these with you guys, but I'll just show you anyways. Okay, so look, on the top, I'm going to have sine of x times 1 minus cosine of x. And then on the bottom, these are conjugates, so all I have to do is first and last. 1 times 1 is 1. Cosine times cosine is cosine squared. And then I know that 1 minus cosine squared is sine squared. So I can rewrite this as sine of x times 1 minus cosine of x all over sine squared x. And then I can cancel one of these guys out, right? So that just leaves me with 1 minus cosine of x over sine of x. Now look, you might be looking at this going, how did I even, like, that didn't even really change, okay? That's why we kind of skipped those when I taught it, but just wanted you to see it just in case you were wondering. Okay, let's look at 78. Okay, so on this one, 2 ways to do it. You can change everything to sines and cosines or factor out a tangent squared. I think in class we factor out the tangent squared. So let me go ahead and change to sines and cosines in case you're wondering if you could do it that way too. So look, tangent squared is sine squared over cosine squared. And then cosecant squared is 1 over sine squared. And then this is minus tangent squared is sine squared over cosine squared. Okay, now check this out. These guys cancel, leaving me with a 1 over cosine squared minus, and then I have sine squared over cosine squared. Okay, but putting these guys together, if I'm subtracting, I need a common denominator, which is cosine squared. They both already have a cosine squared, so the top does not change. So I have 1 minus sine squared on the top. And then you guys, 1 minus sine squared actually equals cosine squared. So cosine squared over cosine squared just equals 1. All of these equal 1, except for 77. Okay, number 79. Okay, so let's do 79 and 80, then we'll call it good. Okay, so for this one, definitely we want to start on the left-hand side. Okay, and let's change everything to sines and cosines. So I'm going to have 1 over... Tangent is sine of x over cosine of x. And then cosecant is 1 over sine of x. Okay, again, you guys, these guys cancel. So I'm left with 1 over cosine of x. But when I'm dividing by a fraction, I'm actually multiplying by the reciprocal. So the reciprocal of 1 over cosine is just cosine, and 1 times cosine is cosine of x. So I got my answer. Okay? And then the last one, sorry about the long video. Okay, what should I do with this? I have no idea. Okay, so let's see what we could do. The only thing I can see is changing this secant to a 1 over cosine. So let's see what that does. So I have 1 over cosine of x minus 1 over 1. I'm going to put that 1 on the bottom so it's a little bit more symmetrical. All over 1 minus cosine of x. Okay, now look, it's telling me to subtract. So if I want to subtract, I need a common denominator. The common denominator for cosine and 1 is just cosine. So this is going to be cosine of x. This is already cosine of x, so this stays a 1. And then minus this needs a cosine of x, so I have to multiply the top by cosine. So 1 times cosine is cosine. And then I'm dividing all of this by 1 minus cosine. But again, you guys, look, if you're dividing, that's the same thing as multiplying by the reciprocal. So this really equals 1 minus cosine of x over cosine of x times the reciprocal of this, which is 1 over 1 minus cosine of x. Okay, these cancel out, and then I'm left with 1 over cosine, which actually just equals secant of x, and that's what I was looking for. Okay, So I hope you enjoyed that. I apologize that was so long. I promise the rest of the videos are not so bad. All right. Have a good day, you guys.